Hi friends, let's start our lesson number 7 for math, and we are still comparing fractions. We were so lucky yesterday, all of our denominators had the same digit. This time we're going to shake things up a little bit, and some of the denominators will be the same, so that makes it fairly easy. But we're also going to look at some fractions that have a different denominator. Today, you are going to compare fractions using the symbols greater than, less than, equal to, and that's 4.3D. And you will compare two fractions and represent them using the symbols. So that is what we're going to do today. So let's get started. And I need your help. I need you to please make sure that you are using your math journal. I want you to use your pencils, pens, or markers, whatever it is your teachers let you use, and always, always pause so that you can write the answer down, and then press play whenever you are ready to check your answer. I would like to start with a number talk, and I'd like for you to help me talk about the identity property of 1. This is 1 whole, one whole dollar, one whole one whole candy bar. It is one entire piece, no more, no less. But what we want to do is take this number 1 whole number, and we want to still make it equal to 1, but using fractions. So what if I use my thirds? This is 1/3. How many thirds do I need to make a whole? Well, I'm lucky I have this virtual toolkit, so I can just put them in here and check it out. It looks like I would need 3/3 to equal a whole. So I'm going to write that down. 1/3 plus 1/3 plus 1/3 equals a whole. So 3/3 equals 1. Okay, that's pretty easy. Can you think of another one? Will you please pause the video and think of another way that you can show 1 whole in fractions? Once you're ready, press play. All right, so what did you come up with? What if we use the fourths? This is 1/4. How many fourths would you need to make a whole? Let's check it out. 1/4, 2/4, 3/4, 4/4. So it looks like 4/4 also equals 1 whole. And I'm going to write that 1 fairly large so that I know that I'm talking about an entire piece. Can you think of any more that would equal 1 whole? So I'm going to ask you to show me two more ways of showing 1 as a fraction. Ready? Press pause and then press play while I erase this. Okay, friends, what did you come up with? Remember, we always want to look at our 1. Did anyone try the halves? How many halves equal a whole? Well, let's check it out. Here we have 1/2 plus 1/2 equals 2 halves. We do not add up the denominators. They stay the same. They have to be common denominators, but we do add the numerators. So 2 halves equals 1 whole. Let's try another one. Did anyone try the 6th? 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. That would equal 6/6, and it still gives me a 1 whole. So I hope you came up with something like this, and I hope that you remember that we call this the identity property of 1. Even though we made it a fraction and it has different digits, it's still equivalent to 1. All right, boys and girls, we're at the part where we do our task A together, and I want you to keep using this fraction bars toolkit. It's a virtual toolkit because it's very helpful. This reminds me of the paper copy I have of fraction bars. I mean, you might or might not have one in the TEAG folder that we gave you at the beginning of the school year. But this is a scenario, task A. We want to know on which day Jose read the most number of pages and the least number of pages, because on Monday he read 4/10 of his pages. On Tuesday, I'm going to write this here, he read 1/10 of his pages. Ooh, I'm liking this. Why do you think I'm liking this? Yep, because the denominators seem to be the same. And then on Wednesday, Jose read a total of 3/10 of his pages. I'll just write it sideways like this. That's still a fraction. And I'm ready to show my fraction. So I'm going to click on the top one. And I'm going to say that I need a denominator of 10. So I've got the 10, 10, 10, 10, 10 as my denominators, but I only need 4, so 4/10 for Monday. I click on the next one. It says 1/10, so I make sure that my denominator, and look, it says it down there is 10, but I only need 1. And then I go down to my Wednesday fraction. It's also tenths. I have to make sure. And here I want 3/10. So I'm going to cover up the extras because I don't want to get confused. I just want to look at the Monday, Tuesday, Wednesday fractions. So the question was, on which day did he read the most pages? Well, if you look at this here, we have the value of 4 of the 10 shaded. Here the value is just 1 out of the 10. And here the value is 3 out of the 10. So to find out what day he read the most, what would you say? Yes, he read the most on Monday. So I'm going to write the most here. And on which day did he read the least amount, the one with the lowest value? Tell me, what do you think? Yes, it would be the 1/10. So I'm going to write least here. Okay, so if I was to write this as a fraction that's being compared, I can say that 4/10, let me see if I can write with my mouse, is greater than 1/10. I hope I'm doing this wrong, friends. If not, please let me know. The 4/10 gets the 2 dots because it's greater. The 1/10 gets 1 dot because it's least. It's the least amount. Okay, I could always move this around and say it a different way. Okay, so I can also say it this way. I can say that 1/10, I made that too big, is less than 4/10. And they would both be true. I would only give 1 dot to the 1/10 because it's less, and I would give 2 dots on these lines to the 4/10 because that has the greater amount. So this is how I would compare my numbers. Luckily, my denominators were common. Now for the next part, I'm still going to be comparing fractions, but this time, oh no, my denominators are going to be different. They're not going to be the same. So I'm going to rely heavily on my pictorial so that I can show the fractions and check to see the amounts that are, where's my paper? To see the amounts that are shaded in, to see which one has the greater value and which one has the lesser value, okay? So here it goes, wish me luck. On this first one, I am going to hammer it down. Let me tell you the situation. Okay, I'll tell you the situation first. This here is a pizza. I'm finally getting to work with pizza. that the boys ate. And this is a pizza that the girls ate. Okay, there we go. All right, so I'm going to hammer it down. The boys, oh, I still have to write my fraction down, ate 3/8 of the pizza. And the girls ate 3/12 of the pizza. And it's already looking kind of confusing because all these digits are different on the bottom, but they're same on the top. But I know that my denominators, my numbers on the bottom of the fraction bar, they should be the same. They should not be different. So I'm going to rely on my pictorial for this. And here it goes. I'm going to hammer this one first. Whoops. All right. So for this one, I'm going to ask for 8 pieces. And for this one, no, you're not going to give it to me? I'm going to ask for 12 pieces. That's how much they they sliced the pizzas into 12 slices for the girls. And then I'm going to go ahead and color it in. For the boys, they ate this much, okay? And for the girls, they ate this much, all right? So what do you think? I'd like for you to pause the video and tell me who ate the most of the pizza and who ate the least amount of pizza. Talking about boys and girls, so please pause it. And you're looking at the purple part. That is what they ate. And I want you to write a symbol. As soon as you're ready, press play again. All right, friends, we're back. So this is the boys ate 3/8, which is the purple. The girls ate 3/12, which is the purple as well. I noticed something. Did you notice that for some reason the boys got bigger pieces than the girls? Yes, their pizza was divided into less pieces, which is 8, but the girls' slices were divided into 12, which makes them very slim and thin and smaller than the boys. So what did you say? Based on the amount that I see shaded here and the amount that I see shaded here, this seems to be more, and it did not for the girls. So I'm going to say that the boys ate more pizza than the girls. Just like that. So yes, that is a situation with the boys and the girls. Now, could I write this in a different way that would still be true about how much the boys ate and the girls ate? How would you write it? Pause the video and write this comparison statement in a different way that would still be true. So pause it, and when you're ready, press play. Okay, so what I would do is I would start this time with the girls, 3/12s, and then with the boys, whoopsie, 3/8s. And I would say the same thing. You know, the one dot was pointing at the girls. I'm still going to say that the girls, 3/12s, is less than 3/8s. And I know this because the numerators on top are the same, but they did not divide the pizzas equally. They made the girl slices a lot thinner, and they made the boy slices a lot bigger. And if they each just ate 3, the girls ate less and the boys ate more. So that is my comparison with the pizza here. All right, now you're coming to a point where you have to do some work. And the work that you're going to do is going to be an assignment that you're going to turn into your teachers. I continue liking this fraction bar toolkit because it helps me look and visualize my fractions. And I've got to remember to click on the ones that I'm working on so that I don't get confused. Usually I just use the top 2, or you may want to use the bottom 2, whatever is easiest for you. So This time, I think I want to use the bottom two, okay? I'm going to use the bottom two, so I'm going to go like this and hope that this works out. Now, this is the scenario. I need to compare and tell whether this is true or false. I'm going to be working with 2/6, and it says that it is greater than 2/3. That's what this first problem is telling me, and I have to decide whether it's true or false. So here I go. I'm going to click the first one, and I'm going to make it into 6. I need only 2 of them, so that is 2/6. I'm going to click on the bottom one, and I need thirds in this case. 2 of them is what I need. So there it goes. Now, what do you think? I've got 2/6 up here, and I've got 2/3 down here. Remember that we're looking at the amount that is shaded in to compare the fractions. They may not be the same amount, so they may not have the same value. The 2/6 has a lesser value than the 2/3. So do you think it's true or false? Pause it and write your answer down and then press play. So what did you come up with? Yes, this is definitely false. 2/6 does not have a greater value than 2/3. I should not be giving the 2/6 the 2 points because it does not have more space shaded in, and the 2/3 should not have 1 dot, which means it's less than, because it is much greater. And I think that what happened here is that they took this one whole and divided it into lots of sections, 6 of them. But the bottom part, the bottom bar, they only divided them into bigger pieces, into thirds. So this one is definitely false. How did you do? Did you answer it right? All right, let's take a look at the next one. The next one, and you're going to have to decide if it's true or false, is telling me to compare 6/8, and it says that it's going to be less than 6/9. I'm going to tell you something. I hope that you are writing this down in your math journal, because these are going to be some of the questions, some of the problems you're going to have to solve in your assignment. And wouldn't it be great if you already did them with me and we did them together, because 2 brains is better than 1. Click on the first one, 6/8. So I need an 8 as my denominator. I need 6 as my numerator. Click on the second one, 9ths. So I go over to the 9ths. I see my 9ths here, and I need 6 of them. There we go. What do you think? I'd like for you to pause the video and decide if this is true or if this is false. Is 6/8 less than 6/9? Once you're ready, press play. All right, friends, so what did you decide? Based on the shading that I'm looking at, I see a greater value in 6/8. Look, it's this much more shaded. And I see a lesser value in the 6/9. So I'm going to say, well, what did you say? Oh, yeah? I'm going to say what you said. I'm going to say that this is false because of the amount of shading that I see. I see more value on the top one, 6/8. That should be greater. I see less value shaded on the bottom, which is 6/9. So this statement is false. Why would it be false? It's false because, well, first of all, I'm lucky that the numbers on top, the numerators, are the same, but they cut the 8s into bigger pieces, and they divided up the 9ths into smaller pieces. So I just justified that as well. So your job is going to be to do the rest by yourself. And I hope you can use these right here. I hope that you can use this, this toolkit. It's so helpful. It's so important. And I want you to see what it looks like. It looks like this is the assignment you're going to do, okay? And boo, none of the denominators are the same. I want you to use your toolbars to figure it out. Tell me if it's true, tell me if it's false, and then justify it. That means tell me why you think it's false. Tell me in words why you think it's true. For the last part, you're going to be doing a cool down. Your cool down is going to have your pictorials already, so you don't need the fraction bars, okay? And here is where you write your fractions. You've got to be practicing those fractions. That fraction game is really good for practicing fractions. The models are shaded to represent two fractions. So you write the first fraction here, second fraction here. In the middle, you have to write this comparison symbol. Is it greater than, less than, or equal to? And tell me why. Same thing here. And then right here, you're going to tell if it's true or false. You will have to use your fraction bars for this one and for this one as well. So there are two assignments that you are going to turn in to your teacher. Make sure that you write your name, your last name, the date, whenever you turn these on. That's very important. So that is our lesson for today. I hope that I didn't forget anything. Please, please, please use the virtual toolkit with the fraction bars. Make sure you turn in the two assignments to your teacher. And I hope that all of this is helping you compare fractions to see which one is greater than, which one is less than, and sometimes they're equal. So have a great day, Tigers.